This is from problem 6.41 on page 258. So turn to there, let's read along. In a sample of 49 employees of a large business firm, the mean number of days in a year lost to illness by the employees was 7.0 with a standard deviation of 2.5 days. And then part A asks, find a 95% confidence interval for the mean number of days lost to illness for the entire company. And part B, how do you interpret this interval? So this problem is quite similar to the one I just worked, and but I want to do a little more with it once we're done with it, because I like this problem because it appears in Chapter 7 in a different way, and we'll look at the Chapter 7 problem afterwards. So hang on for that. All right, now I wrote the essentials down here. The mean number of days lost due to illness was 7.0 days per year. Standard deviation was 2.5 and is based on a sample of 49 employees. They're asking for 95% confidence, which means that alpha, the type 1 error, is 5%, 0.05. All right, so our first thing to do is to calculate the t-score based upon alpha over 2, probability, and the degrees of freedom. In this case, again, half of 0.05 is 0.025, and the degrees of freedom, one less the sample size for this type of problem, is going to be 48. 49 minus 1, 48 degrees of freedom. So let's look that up on page 651, I believe. 651. Okay. So we'll go down the line where it says 48 degrees of freedom and go across under the probability for 0.025, and this time I get 2.01. So that t-score is 2.01. Now, in the last problem it was 2.23, wasn't it? Why was it larger in the last problem? Well, that's because we had a smaller sample. We had a sample size of 11. In the last problem, now we have 49 people. So that means there's not as much sloppiness in our calculation of the standard deviation. You know, it's a sample standard deviation. That means it's subject to randomness because we do not know the population standard deviation. So, you know, the sample standard deviation, just like a mean, is subject to some random variation. In order to handle that slop, that's why William Gossett, came up with a Stew's t-distribution. Well, with a larger sample size, this t-value is going to drop down, and it gets close to what you would find on the standard normal curve, the z distribution, and which would be actually 1.96 in that case. So anyway, let's we'll be using the same formula to calculate the confidence interval. And so that is x bar minus the t-score, 2.01, times standard deviation divided by square root of sample size, comma, x bar plus the t-score times standard deviation divided by square root of sample size. And if you need to refer back up the video to the other formula, you'll see exactly where these numbers are coming from. All right, so let's calculate that. So now it makes it kind of easy because the square root of 49 is 7, so I'm going to enter 7 when I do that. Calculating the margin of error, 2.01 times 2.5 divided by 7 is 0.72. So our margin of error is 0.72, which means that the 95% confidence interval is mu belongs to the range of values. Mu belongs to the range of values from 6.28 up to 7.72. All right, so there's our calculation. Now, I'm pretty sure I have some students who'd be glad to just stop there. Oh, okay, we did a calculation. Great, we crunched some numbers. We're done. Well, you know, this course you also have to explain what you did, so that we know, you know what you're talking about. All right, we know, you know, because the idea really is to know what all this means, not just to do calculations. All right, so I'm going to write down my interpretation. This is answering part B. How do you interpret this interval? Okay, so I need to do a little bit of erasing.